Hi, greetings everyone. Thank you for joining us at Exchanging Ideas 58 Global 5G Evolution. To the audience there, please take a couple of seconds to click the subscribe button on our YouTube channel. A warm welcome to all the speakers around the globe. I really grateful and appreciate for all of you to come in this event. Without due delay, I would like to actually express that to the audience that we will have a fantastic debate at the end of this session, and the topic revolves around telcos behind the AI curve. So to the audience, please do check out at the Q&A at the end of the session. This will be a fantastic debate. Now, I will be presenting the topic on ITUR updates, which is 5G towards to the 6G. And IMT 2030 aims to significantly enhance the 5G capabilities with faster speeds, lower latency, greater capacity, and improved support for a massive number of connected devices. And 6G is envisioned to enable the transformative applications like truly immersive extended reality, advanced robotics, ubiquitous IoT, and other future innovations. Now, the WRC 27, which is to be held in 2027, is a crucial event organized by the ITU that will address the global spectrum allocation and regulation. This conference will focus on identifying and allocating spectrum for 6G and the continued expansion of 5G alongside addressing the spectrum needs of satellite services, the IoT, maritime, and aeronautical communication. WRC 27 will also strive to harmonize the spectrum use internationally, ensuring the efficient and interference-free operation of various radio frequency services. Now, this slide highlights the ITUR report M2516, which explores the future technology trends impacting the IMT systems up to 2030 and beyond, including drivers, emerging technologies, and enablers for both radio interface and network enhancements. Additionally, ITUR report, which is M2541, investigates the feasibility of utilizing frequencies above 100 gigahertz for IMT. And this report, along with recommendations of ITR M.2160, establishing the overall framework for IMT 2030, providing the basis for creating the next gen of mobile communications with a focus on emerging trends and technological advancements. Now, this is the recommendation of ITUR M.2160 as the functional doc outlining the vision and direction for IMT 2030 and the standard for 60. And this recommendation identifies and defines the core capabilities that IMT 2030 should possess, such as data rates, reduce latency, improve spectrum efficiency, and support for a massive number of connected devices. And essentially, M.2160 provides the roadmap for the development of 6G, guiding the work of technical experts and standardization bodies in creating the next generations of mobile communications. Now, this slide highlights the societal motivations like inclusivity, ubiquitous connectivity, and sustainability alongside user trends such as ubiquitous intelligence, immersive multimedia, and digital twins. And this document emerging technologies and enablers for both radio interface and network enhancements, including the summary FTT. And it specifies the need for multiple frequency ranges from sub 1 gigahertz to above 100 gigahertz, meet diverse requirements, stressing the importance of low bands for coverage and higher bands for capacity in 6G. And also this doc advocates spectrum harmonization to achieve economics of scale and global roaming. And also it acknowledges the potential of bands above 100 gigahertz for supporting high data rate and low latency applications in IMT 2030. Now, this is quite interesting hexagon highlighting the 6 key usage scenarios: the EMBB, enhanced mobile broadband, evolving into immersive communications, the MMTC for massive communications, and the UR-LCC advancing to the hyper-reliable and low-latency communications. And the three new additions are the ubiquitous connectivity, the AI and communications, and integrated sensing and communication. And these scenarios are contextualized within a wheel diagram emphasizing four overarching aspects that should guide the 6G design. So definitely the ubiquitous connectivity, sustainability, connecting the unconnected, and security resilience are the key areas in this aspect. The 15 key capabilities with 9 derived from 5G and 6 representing new advancements in areas like AI, sensing, and sustainability. And this palette diagram visually represents these capabilities, emphasizing security and resilience as crucial, alongside metrics like peak data rate, user experience data rate, spectrum efficiency, latency, mobility, connection density, and area traffic capacity. And it notes that the provided capability ranges are targets for research and investigation with all values with having equal priority. IMT 2030 aims to contribute to environmental, social, and economic sustainability, aligning with the UN's Paris Agreement on climate change as well. Now, ITU M.2541, a report investigating the feasibility of using frequency bands above 100 gigahertz for 6G. And this report acknowledges the need for wider bandwidths around 10 of gigahertz to support 6G high data rate and low latency requirements, necessitating the exploration of spectrum above 92 gigahertz. M.2541 details radio wave propagation characteristics in the high frequency bands, including the channel modeling and measurement results. The report further explores enabling technologies such as advanced antennas, semiconductors, reconfigurable intelligence services, the RIS, and MIMO and beamforming as well. Also outlines the potential deployment scenarios and architectures for 6G in those higher frequency ranges. And lastly, this focuses on the interplay between satellite and terrestrial networks. It highlights 3GPP's ongoing work on NTN within release 17 and 18, specifically for new radio and narrowband IoT, with a future outlook in release 19. Also, the use of mobile satellite services spectrum versus IMT band for NTN, listing specific frequency band under considerations. It also raises the question of GSO versus non-GSO satellite orbits and whether IMT technology will be employed in NTN. Key assumptions for NTN implementation are listed, including the single versus massive user devices, fixed versus mobile UEs, and indoor coverage. Definitely, I would say that from now till 2027 onwards, there's a lot of drastic actions, measures are taken in order to see how we can converge the NTN with the TN, terrestrial network and non-terrestrial network, and see how we can improvise together. So I think that's all the presentation from my side. Just one second, let me try to stop sharing this. And I would like to introduce our next speaker, Dr. Loha Hashimi from Barcelona, Spain, to present on lessons learned from 5G routes project and results of advanced large-scale field trials of most representative CM applications to demonstrate seamless functionality across prominent 5G cross-border corridors. Over to you.
Thank you so much. Good morning, everyone. I will try to, let me see in which slide I am. Yes, now, can you see my screen?
Yes.
So my name is Lola Shimi. I work as Senior Innovation Manager in a company called INIDE, and we are involved in this EU-funded project called 5G Routes. And today I will be presenting a little bit about this project, and since the project is reaching its end, the lessons learned from this project. Before deep diving into the project itself, I wanted to explain to the audience, probably outside Europe, about some activities that are taking, or some missions taking place, strategies in Europe. As part of those strategies, then such kind of projects being funded. First of all, 10T is planned in Europe for transport and logistics as backbone for moving of goods and people across European countries, and that includes railways, roads, waterways, and airport. And 9 core network corridors connecting the most important nodes are planned by 2030. And comprehensive network is planned to be established all around EU regions by 2050. And another to reach to 10T, innovation and new technologies and digital solutions are planned to be implemented for all modes of transport, and the deployment of 5G cross-border corridors along transport paths through Europe is expected to contribute to the green and digital transformation of EU economy and society. Part of this strategy and plan is a 5G-enabled, connected, and automated mobility initiative, which is seen as a major enabler for improved road safety, optimized road traffic, reduce carbon dioxide emissions, and industrial competitiveness of both the transport and mobility sector. I'm focusing on both 5G, but also CAM, because connected and automated mobility is also a strategic goal for European Commission. And then combining these two topics, they launched call for proposals, and lots of companies and consortia applied for that. And 7 projects were funded under this under these calls from Horizon 2020, such as 5G Carmen, 5G Croco, 5G Mobix, 5G Mid, 5G Roots, 5G Blueprints, and 5G Rail. So as you see, as part of these 7 big projects that were funded by European Commission, 5G Roots is one of those strategic projects that EU funded in order to test 5G, but with a specific application in mind, which is CAM. So 5G Roots is 11 million project with 22 partners, which is started in September 2020, and is expected, as I was saying, to be ended in February 2025. And the vision of this project is to conduct advanced field trials of innovative CAM applications seamlessly functioning across a designed 5G cross-border corridor, which we call via Baltic North, in order to validate latest 5G features and 3GPP specifications under realistic conditions. The focus is to demonstrate service continuity and cross-border scenarios for autonomous and automatic systems such as CAM. And there are several scenarios that will be considered and tested. First of all, we will have cross-border scenarios tested in Finland, Estonia, and Latvia. Then we have cross-telecom operator. We have Telia and LLM as partners. 5G terrestrial and non-terrestrial backhauls, such as satellite coverage, but also multi-hop, and cross-transport mode settings such as rail, road, and ferry. All these scenarios are tested in the project. The objective of the project is, first of all, to develop commercial CAM applications for automotive, rail, and maritime and border settings. Then the second objective is to define needs for larger scale CAM trials in the Via Baltic North 5G corridor, and then optimize AI-driven solutions for seamless, reliable cross-border CAM services, upgrade existing assets, integrate enablers, and test in lab and field trials, validate 5G technologies in real-world cross-border deployments to boost adoption, develop sustainable multi-operator CAM business models with cost savings and revenue streams, because if there is no business model and there is no revenue, then we will not see adoption. And then align with telecom and automotive standards to ensure interoperability and share results while they collaborate with 5G initiatives and support EU 5G and CAM strategies, as explained before. There are 5 use cases in this project. We call them cluster of use cases because for each one of the use cases, we have then sub-use cases that I will deep dive to in the next slides. The first one is automated cooperative driving. The second one is awareness driving. Then we have sensing driving and interrupted infotainment, passenger services on the go, and multimodal services. So under each one of the cluster of the use cases, then we have sub-use cases, specific use cases from the business perspective that will be tested in the project. For the first use case, we know that automated driving reduces driver involvement, but requires key technologies in vehicle and communication networks. So 5G, V2X communication, AI, edge computing, and dynamic mapping has some examples of the technology and its visibility and decision-making by enabling real-time data exchange between vehicles and infrastructure. Make-enabled 5G RAN nodes with AI provide the intelligence needed for safer and more efficient autonomous driving. And the 3 use cases we have, or sub-use cases we have in 5G that are tested are dynamic vehicle plotting. Vehicles form a cluster traveling group dynamically. And then the second one is cooperative lane change, where vehicles coordinate lane changes to improve safety in traffic. And the third one is see-through view, which enhances road visibility to prevent head-on collisions during the overtakes. The second use case ensures reliable road traffic data exchange via V2X communication by enhancing real-time traffic monitoring and collision avoidance in complex intersections and traffic jams. And the sub-use case is real-time traffic and collision control, which provides enhanced visual monitoring and automated control at intersections for safe passing and avoiding collision with vehicles and vulnerable road users. The third use case is has the objective to ensure and enable connected vehicles to share sensor data with enhanced situational awareness and VRU protection, even beyond driver's lane of sight. And it also supports the predictive maintenance for long-term vehicle reliability. Though this predictive maintenance part was later on removed from the project because we focus on some important use cases, and it was not part of it. So the 2 use cases that we actually tested was sensor info sharing, where vehicles collaborate by exchanging sensors data to improve safety on motorways. And the second one was VRU collision avoidance, which ensures safer interactions between vehicles and passive VRUs to prevent accidents. The 4 cluster of the use case aims to ensure seamless 5G connectivity for multimodal passengers across 5 EU borders, enhancing both productivity and entertainment. So while the 2 other use cases previously explained focus on VRUs, this one is more on productivity and entertainment, where end users will test 5G-enabled apps and provide feedback on experience and business potential. The 2 sub-use cases are a 360 immersive gaming, which is in a high trend nowadays, where we tested uninterrupted multiplayer gaming across different transport modes, automotive, railway, and maritime. And then we have 3D virtual collaborations, which tested seamless real-time 3D collaborations for business continuity across borders and transport modes. The second use case with the e-working or teleworking seems to also be a really important use case from the business perspective. And the fifth and the last cluster of use cases ensure seamless rail transport digitalization with uninterrupted service for passengers and real-time tracking of goods across different transport modes, automotive, rail, maritime, and 5G networks, both terrestrial and satellite, as mentioned in the earlier slides. And the 3 use cases we tested here are first goods tracking, which enables cross-border multimodal tracking of goods using massive machine type communication or MMTC over terrestrial and satellite 5G networks. Then the second one was passenger and freight management, which provides proactive multimodal coordination for travelers and cargo across border and transport modes. And the third one is FRMCS telemetry, which enhances railway telemetry operations for improved services available, and also the performance. Just to wrap up, I mean, we tested all these use cases in the project. And since the project is ending, some lessons learned from the project, first of all, is that we had some challenges in maritime connectivity. The existing terrestrial networks are insufficient for seamless 5G coverage over open water, which necessitates satellite and multi-hop connectivity solutions, which we also tested. The second one is architectural innovation for maritime scenarios, combining satellite backhaul and multi-hop connectivity between vessels, which can extend 5G coverage for real-time cargo tracking and passenger services. We also had some challenges with AI-based technological enablers. We know that AI-driven solutions like multi-access edge computing, end-to-end slicing, and dynamic spectrum management are crucial for optimizing 5G-enabled connected and automated mobility. While these technologies were tested, still we believe that they are not mature enough, actually, and further piloting and testing is required. Network optimization for seamless mobility, ensuring uninterrupted 5G connectivity and cross-border mobility requires dynamic network slicing, real-time handovers, and interoperability between different telecom operators. The most important part is this interoperability between telecom operators, which seems to be still a challenge. There's a lot of work which is still needed. From the operation and deployment perspective, some lessons learned are importance of cross-border collaboration.
Dr. Loha, that time is already over. So would you mind to quickly wrap up, please?
This is the last slide. I'm going to finish this one, and then I will leave the floor back to you. So from operation and deployment perspective, we had the importance of cross-border collaborations were highlighted, and deployment delays due to regulatory constraints. Still, we are facing some gray areas from the regulatory perspective. Infrastructure is still not ready and compatible for lots of use cases, and there are lots of issues on that. And from the management perspective and external factors, as I was saying, impact of regulatory and environmental challenges, such as COVID, actually, which caused some delays for the project, and a need for adaptive project management for such huge consortia. It's really important, actually, to be flexible and sometimes shift the priorities when needed. The stakeholder engagement and ecosystem building is also crucial in order to cover other challenges that were mentioned previously in a more collaborative way. So with that, yeah, I'm giving the floor back to you. Thank you so much for the attention.
That was a great explanation. Thank you so much, Dr. Loha. I appreciate that. Let me introduce our next speaker, Ivan Palama from Rome, Italy, to present on 5G positioning and security.
Thanks for the introduction. So, would you please confirm you can see my slides?
Yes, sir.
Okay, perfect. So, welcome to everybody. I'm Ivan Palama, and I'm the head of research at CNIT Network and Assurance Monitoring Lab in Rome, Italy. And today I'll try to provide my vision about 5G positioning and security from an academic point of view. So, this is the outline of my presentation, and starting from the 5G positioning, I'll try to provide some primer regarding positioning. So right now, positioning, we can say that radio positioning is the estimation of the user location using waveform measurements from network and node. Oh, sorry, I have some problems with my slides. Okay, yeah. So we know that the waveform convey information about the geometry, so we can exploit those information in order to know the environment. And we can do that by taking some measurements from the signals. So for example, we can extract the signal strength, an information about the time, the angle, and the velocity of some targets inside the environment. And in 5G, 3GPP standardize both signals and some methods in order to do that. So they standardize the PRS, the position reference signal, and the SRS, the sounding reference signal, in downlink and uplink, respectively. And in order to measure the user position, they also standardize some methods, such as the downlink time difference of arrival, the uplink time difference of arrival, and the multi-RTT. In the downlink time difference of arrival, what happens is that multiple synchronized base stations send the same signal to the user equipment that measure the time of arrival of those signals, and then send it back those measurements to the network. There is a specific function inside the core network that is called LMF, location management function, that actually is able to compute to estimate the user position using those information. As I said before, they also standardize other methods, for example, based on angles that exploit more or less the same structure and the same procedure in order to estimate the user location. If we have a look to the 3GPP standardization effort in the last years, actually they have done a lot of work in order to improve the capabilities of 5G. They enable a lot the 5G positioning also for low power devices with the reduced capabilities. They also enhanced the performance of 5G positioning by, for example, introducing carrier phase positioning and sidelink positioning in order also to also to cover other areas without direct connection with the main network. But if we have a look to the specific security part of 3GPP standardization efforts, they try to standardize some security aspects focusing on integrity. And how they done it, simply they try to take the knowledge of global positioning systems and try to apply those knowledge to the 5G positioning. So for 3GPP, the security is integrity, and the integrity for us is a measure of trust in the accuracy of position estimate and the capability of providing timely and valid warnings when the positioning system does not fulfill the connection for the intended operation. And they also leverage the well-known indicators such as the alert limit, which is the alert tolerance that you have to not exceed without issuing an alert to the user, and the time to alert, that is the maximum allowable time that elapses from when the system being out of tolerance create an alert, and the integrity risk, that is the probability that the positioning error exceed the alert limit, and the protection level, which is a statistical bound computed in order to guarantee that the probability of the absolute position error exceeding the number is smaller than or equal to the target integrity risk. So actually, they have a framework in order to manage the integrity of 5G positioning. And from my academic point of view, we can say that we have the 3GPP specification, but in the research jungle, we have a lot of problems which are not fully addressed from 3GPP. And if we have a look to the physical layer, and in particular to the physical layer security, in 5G positioning, we have a really critical area that we have to manage, to properly manage. And for example, if we have a look to the most well-known attacks in the 5G physical layer positioning security, we have two kind of big areas that are the overshadowing attacks and the spoofing attacks. So very briefly, in the overshadowing attacks, an attacker actually capture the signal and then replay it with a higher power in order to overshadow the legitimate signal with the malicious one. In the spoofing attacks, a malicious actor actually create a malicious signal without capturing the legitimate one, and once they create the malicious one, they inject the malicious signal with a higher power inside the legitimate communication in order to inject the malicious information inside the communication. And if you have a look to the 5G positioning specifically, we have a lot of researches that actually highlighted those problems in 5G positioning. But the biggest problem actually, from my point of view, is that those attacks require a complex implementation and are required to be synchronized with the ongoing communication. And so what we have done as a group, as a research group, is first of all, we studied the new standard, the new ISAC scenario in which we have integrated sensing communication. So we use the network to both sensing and communicate. In fact, ISAC integrates sensing a spatial location of passive, non-connected objects into the mobile communication network in order to expand the functionality offered by the network. So very briefly, we have both communication signal and sensing signals, and we exploit the communication, the transmission of signals in order to both communicate and sense the environment. And we have also three modes in order to do the sensing part. We have a monostatic mode in which we have a single transmitter receiver which sends as a radar the network, the environment. We have a bistatic scenario in which we have a separated transmitter and receiver, and we can also have as a broad network like the 5G one, a multi-static scenario in which we have multiple nodes that actually cooperate in order to sense the environment. So focusing on those new scenario, we try to experiment some activities in order to validate the vulnerability that we found inside those scenarios. And in order to do that, we leverage some software-defined radio in order to accelerate the transmission and reception of the signal. We recreated a private network using open source software such as OpenAir Interface and SRS-Run. And in this case, as represented in the slide, we use the Amarisoft Radio Access Network in order to recreate the run, and in order to also confirm our conclusions, we also leverage some Keysight spectrum analyzer. So what we done, as you can see in the slide, we created the network. We have the base station. We have the spectrum analyzer in order to better understand what is going on. And we have two kinds of users. The normal one, which is represented by the smartphone on the right, which is the user for the communication service. And we have also another user, which is represented by the SDR on the right, the X310, which is the user that actually is able to receive and compute the time of arrival, which is needed in order to perform the user localization. And between those two base station and user equipments, we inserted a malicious actor. And the attacker actually is able to receive and transmit the signal. And by leveraging FPGA-based script, it is able to do it very fast. So actually, we are able to receive the signal, the legitimate signal, and send it back to the user, to the victim user, within 3 microseconds. So actually, we are able to disrupt the positioning services, but since we are really fast, we are able to not disrupt the communication services. So the attacker is able to cope with the positioning services, is able to disrupt the positioning services without disrupting the communication. And this is really critical in ISAC scenario. And as you can see here in the slide, we have the correlation that actually show that an attacker is able to insert a malicious peak inside the time of arrival measurements. And in the table, actually, we can see that by using the Keysight spectrum analyzer, we are able to see that when the attacker is present with the attack, actually, the strength of this reference signals is higher. So actually, the attacker is really able to insert the signal inside the legitimate communications. So actually, we can draw some conclusions, and of course, we have to say that in this scenario, an attacker, even without complex synchronization requirements, can attack the 5G positioning services, the service, and also in ISAC scenario is able to disrupt the 5G sensing service at physical layer. And it's imperative for us to think about a 5G network and future 5G network system that must proactively detect and neutralize those threats in order to safeguard the integrity of the sensing and positioning services. So I suggest the research community, and as a researcher, I'm focusing in order to integrate a real-time surveillance to promptly identify any anomalous behavior, such as a full frame mimicking attempts, as the one that I showed before, that can target positioning data without affecting communication. And we have to design the network so that the defensive mechanism do not compromise communication services, of course, ensuring uninterrupted, secure operation for all the customers. So that's all. Thanks for the attention.
Oh, that was an amazing presentation. Thank you, Ivan. I really appreciate that. Let me introduce our next speaker, Dr. Catherine Kine from Geneva, Switzerland, to present on expanding horizons, the convergence of 5G, quantum computing, and AI in the shaping the metaverse ecosystem. Over to you.
Thank you so much. Yes, so I am the member of the board of advisors for the Swiss School of Business and Management in Geneva, in Switzerland, where I am located. Um, I'm also a professor for quantum computing and AI applied to business, which is what I would like then to talk to you about then today, which is number one, I would like to start with the difference between what quantum computers are versus a classical computer, and then give you here overview about how it can be used for the metaverse. And then from here, how the quantum computing can be used as a platform that can unify all domain services of network data. And then about moving into the metaverse. Well, what it could be doing? An example here and a use case that I'm proposing is that to have a marketplace with 5G that can power metaverse digital twins of different industries. And at the same time, well, what is the business case from that? Because I'm a professor of AI applied to business and quantum computing. Well, then one use case that I would like to concentrate today would be on monetizing, giving you how to deliver on near term, on short term, and long term monetization goals that can happen even right now at the state where quantum computing is. So, from a classical computer, yeah, they are usually based on the theory of using binaries and bits. So, electricity, no electricity. And quantum computers, they work at the same time, the zeros and the ones, they're called qubits, and it's based on the quantum mechanics laws. So there is still, of course, the Max Planck theories, and a lot of research still needs to be done independent on what a very big mogul on for a very big company might say about quantum computing. There are already established quantum computers that are accessible to the public, for example, from Google or from Microsoft or from AWS, which is what we use for our particular research project, over the cloud, of course. So, what is the advantages of quantum computing? Well, classical computers are used for standard data and simple calculation, and quantum computers process at the same time complex computation. So that means that you can have parallel data sets, multiple, and do probabilistic computations within milliseconds at the same time. So, yes, the advantage of classical computers, because they have been here for so long and they're pretty advanced, there's low error rates, and they can be kept at any room temperature and brought anywhere. Quantum computers require at least then minus 27 Kelvin. So, due to high error rates, although the new chip from Microsoft has reduced error rates by 50%, they have to be kept ultra cold. So, Information is subject to the law of classical physics for normal computers, and quantum information obeys the laws of quantum mechanics. So the idea here is that we're proposing to use technologies to leverage quantum computing in different industries with the power of artificial intelligence, the power of generative AI, blockchain, and machine learning. One can achieve quite a lot more. So, but nevertheless, I also call myself #data mad scientist. And an important thing is to ensure that one has an excellent platform for data, even for quantum. So the data has to be aligned to the particular business organizational case that you might have. And one thing here, because one is moving quite fast, there has to be an agile global delivery, a reliability focused support, flexibility and coverage, and absolute and maximum robust data governance. Because one moves quite fast, one does have them the ability then to test if the data set is adequate or not. So for this, we delivered AI ML based capabilities on a modern enterprise to check this. So one of the things here is that we see is that we can enable consumption patterns that are completely different. We're able to orchestrate different type of experiences of system orchestration with different profiles, with what would be the different type of insights, and just simply do multiple combinations of use cases at the same time. So what we're working on through accessing it through a 5G, that means creating even portable access from wherever we are. We're able to create models for customer experience, finance, and ensure that also very important, they're still compliant. Responsible AI is still at the heights, particularly since the EU AI Act has come into place since February the 10th in the EU. So the legality and the law must be put in place through responsible AI practices and be enforced. An important part of this is also to ensure that there are particular timing and management operations for the business of this, means processes and methods into place, and also business functions that support this idea. So think about this, that you create also an organizational structure in order then to establish, based on the industry, the particular data set, based on the particular use cases, the methodologies, overall as data governance, overall responsible AI for governance. And from here, then you can start using generative AI to search with your data and converse with your data to find out what would be new ideas for collaboration. But this is, of course, then moving on into the metaverse. We propose here that with the possibility and the mechanics of the use of 5G and the power of digital twins in a particular quantum computer that is able then to process complexities. One can have what would be here, you see an example of an entire digital twin, for example, of an intelligent smart city, in which you can see, for example, you can have a digital twin of manufacturing, a digital twin of an entertainment with a fan experience, a facility for mobile AR, VR gaming. So as the computers have a lot of performance power, the ability to be able then to engage with what would be the different type of activities is absolutely in real time, is very, very fast. Can also be used then for healthcare, which is also another use case that we use for remote care. A lot of different type of villages in certain areas in the world cannot have access to a doctor. So by the use, for example, of 5G through Star and also connection for Starlink, and a particular then access over the cloud for this, enable, for example, a healthcare remote care be able then to give them the same thing as power drone ambulances and supplies to go into what would be fragile regions. And another point it is in agriculture. So we were able to create models for crop maintenance and pesticide spraying, and also create what would be a digital twin to see and test some soil amendments. So that would mean to see if the particular fertilizer would be affecting the area or there would be some kind of water contamination. So what would be the right doses in order to avoid it, and later on what would be transported to a water treatment plant. And an excellent power and an excellent case would be in automotive, where we can completely bring on about the whole of the NM plus driving scenarios that could happen, as well as what would be all the different functionalities and complex cases. That means test end to end for the first time, all functional requirements of an automotive vehicle, in order then to also test what would be the one of the most difficult cases, and that is that of autonomous driving. So from here, as you can see, the power and the use cases of bringing about digital twin, the metaverse, is that they can all interact with each other for the very first time. Think about living in a video game in which you can participate in all this normal type of different activities at the same time. But what would be then the business case of having this? Well, one can leverage and start bringing new ideas of your current business, so you can test your business ideas before they even become and entering an adjacent business. You can develop new business ideas and test them with an absolutely low risk because it's all a simulation. So that means this can leverage and enhance your data for your core business. You can seek new opportunity areas, and then you can try to look for even new data sources that you didn't thought about. That would mean, for example, combining what would be then the aspects of the automotive world, and for example, then with agriculture, on bringing what would be then new transport type of methods, or just in time, for the particular farms. You could develop new insights. That means that you could try and test different deep client insights because you can simulate them yourself along an entire smart city blockchain. You can use this for marketing and RA conversion. And also, you can later on move it into monetize it with analytic capabilities and test how well this white label capability and processes would be to commercialize something new. So for example, if you created what would be an excellent AR VR game, you can test it and simulate it how people would react on real time, and at the same time create new data for what would be then testing what would be your marketing capabilities for your new game. And at the same time, you're not just simply having a digital twin alone. You can partner with other adjacent players, and this could be able then to give you very valuable feedback and bringing about a new value chain of information. And you can contact a new type of users or your potential users and find ways to cooperate, bringing new sources of data with existing data sets by trying and testing with other development partners or users. And then later on, you can monetize this and then bringing it about, for example, as a set of validation tests. And another very, very important point of view is that you can create absolutely new offerings that might have not been able then for your particular business because you didn't have the data or the connection to what would be adjacent industries. And for the very first time, you would be able then to have that particular access to develop these new sets of analytics and data products from these adjacent industries. So for example, if you're doing marketing, it would be media and also social media, you can test it directly on the metaverse and then develop new products that can benefit from this enhanced data and analytics. So as you can see, the areas now of monetization, the new areas then of business can be now accelerated through the power of quantum computing, AI, and then of course the power and protection of a good 5G network. From that, I want to thank you very much for your attention and thank you very much for the invitation.
Oh, fantastic. Thank you. That was amazing. Thank you so much, Dr. Catherine. I really appreciate that. Let me introduce our next speaker, Nikolai Sudarikov from London, UK, on how AI is revolutionizing strategy consulting.
Okay, thank you very much. Let me share my screen. Can you see it?
Yes, sir.
Perfect. Okay, so my name is Nikolai Sudarikov, and I am CIO of Hypothesis 3. So basically, we are aiming to revolutionize strategy consulting. I don't have any kind of consulting background myself, but my co-founders do have. I am a technology guy myself. But nevertheless, I think that we need to start with introduction of how consulting process normally can look like. So everything obviously starts with a client problem. So a client goes to a consulting firm, usually with their own definition of the problem, but it's not enough. So any good consultant needs to redefine that problem in a better way. And that usually means adding some smart criteria to that, defining success criteria, scope of the problem, and so on, identifying all the stakeholders. Then goes structuring the problem. So that means that you need to break it down into smaller issues, or sometimes you need to go straight away to hypothesis. And then you need to prioritize those based on the potential impact and how hard to do the analysis. Then goes planning for analysis themselves. And basically that would be a whole work plan for the consulting team who is doing what. It includes research, data analytics, and multiple other things. Then the work itself is done, so that's the core of the consulting project. It can usually take weeks and sometimes even months. So multiple people doing a lot of analytical works in parallel, and then goes phase of synthesizing all these findings together. So the whole team trying to understand what was found during the analysis and how this all makes sense together, what data telling us, and so on. And then the final stage is to develop recommendations. Sometimes it goes with implementation plans, sometimes it's not, but basically classical strategy consulting stop here and then goes implementation. So that should require very good communication to clients, because it's not only about recommending what to do, it's just convincing a client to do it actually, because if the project will not be implemented later on, it doesn't make any sense. Okay, so in this, I think last 50 years or so, it was very, I think, traditional ways to do consulting. And there were obviously companies dominating this field like McKinsey, Bain, and BCG. So I think that they were relying heavily on their proprietary frameworks for different industries and domains, and they try to protect this as the huge assets, and all the knowledge was concentrated within those firms. But now things are changing, and a lot of this knowledge becoming open and available. But then still, the consulting process was always labor intensive, so it requires a lot of efforts and time, and it requires highly analytical people and generally very smart people, and the cost of consulting is also usually huge. So typical McKinsey project would start from like £500,000 at the very, very basic level. Also, it is slow. It requires a lot of coordination across multiple people, and within a consulting firm and outside with the client organization. So it's typically takes some few months to complete a project on average. Also, subjective insights a big problem, because we need to rely heavily on individual experts' opinion, and of course it is hard to scale. So now how AI is changing all of that. So AI can bring standardized methodologies, so multiple people can work remotely, and AI will synchronize all the efforts of these people together around one standardized methodology. There can be a lot of help from AI to automate the process, which I will show you in the second part of the presentation. Also, AI can significantly reduce the project cost and make it 3 or 4 times faster to complete the project. Well, that's why the cost efficiency is coming, because we need to use less time from these smart, intelligent people, consultants, and do more of the AI work. And yeah, it will be always based on data. Recommendations always should be evidence-based, because otherwise there will be no buy-in from the client side. And with AI and technology in general, it's much easier to scale projects and do more projects with the same number of people. So now I will go to the practical aspect of it and how AI is changing this. I will use our hypothesis tree as an example, but obviously there is much more different tools that are available today and will be available in the future. So that's the first part of the consulting process. So how AI helps us to define problems. So I think usually we can start with very simple problem definition that comes from client. For example, client has a specific problem. Revenue is declining. They want to understand the reasons. They want to recover their revenue, gain some market share, and so on and so forth, or enter new markets. So multiple different types of problem. We will put it in a very simple way, just a couple of sentences, and then what AI is able to do, it can help you as a consultant to redefine a problem with a smart criteria, like specific, measurable, and so on. Then it will identify a situation and complication. So it will clearly separate what is like situation and complication for this. And then it will also suggest a scope, criteria for success, constraints, stakeholders, and sources of insights. Of course, it is just a suggestion, so AI cannot fully automate the process, so we still need human intelligence there, of course, but then it is taking much less time and much less human energy to do that. So it is at least a good starting point. So then what goes next is problem structuring or problem breakdown. So AI can help us to break down a problem into hierarchy of hypotheses, and hypothesis will become a foundation for the potential solutions. However, before hypothesis can become a recommendation, it should be proven or refuted. So for that reason, AI can come up with a list of analyses that should be done for every hypothesis to prove or refute it. And then what AI is already doing for us, when analysis is done and a consultant provide findings for this analysis, AI can automatically validate the hypothesis and say, okay, this is enough evidence to prove or refute it. Or if it's not enough, AI will suggest what is missing and provide further guidance. Yeah, and then AI can create a full analysis plan. So for every analysis, it will be detailed, contextualized instructions with examples. So previously, how it worked, you have a lot of different usually internal frameworks with a lot of instructions how to analyze specific industry, but this was very generic, and every time consultant needs to slightly adjust this methodology to their specific use case. Now that's the beauty of AI, it will, based on the learning provided previously about different case studies and projects, it will come up with contextualized instructions and examples, and it's now much easier to do this for consultants. Also, we already have experiments that AI can fully do analysis from end to end. So for example, consultant just upload last 5 years of sales reports, and AI will identify trends and extract necessary insights, not for all of the analysis, but for some of them. And final is communication. So synthesis, when AI helps to put everything together, all the hypotheses, all the analysis into a so-called storyline, which will use a pyramid principle to create a compelling narrative that can be used later to create a presentation and start recommendation phase from here. So I think that a key takeaways here is that still it's a lot of problems we need to solve, specifically around data privacy and security. So many consulting firms not ready to share their knowledge or their client data with companies like OpenAI or Google or Microsoft. So we still need to consider private cloud deployments with open source models and so on. Of course, we are not saying here about replacement of human consultants. It's just about augmentation. And then a big trend these days is explainable AI. So AI explains all the decisions and so on, which creates a lot of transparency and helps a lot to build trust into what AI recommend to consultant. And going forward, it's a lot of opportunities to integrate market intelligence and track all the data in real time and provide real-time suggestions. So a consulting project itself can be, like live environment with changing variables in real time. And I think also very interesting part can be dynamic scenario planning. I think as previous speaker mentioned as well, this kind of simulations will become much easier to do with the rise of AI. Yeah, I think that's it for me. Thank you very much for your attention.
Great stuff. Fantastic. Thank you, Nikolai. I would like to introduce Sabah Fatima from Los Angeles, USA, to present on 5G and the future of connected medicine, revolutionizing healthcare through technology. Over to you. Would you mind to unmute yourself?
Oops, sorry about that. Well, let me go back to this part and let me know if you guys are able to see my screen okay.
Yes.
Okay, perfect. Hi, everyone. My name is Sabah Fatima. I'm actually from Southern California, and I pursued a master's in public health at New York University. The reason why I did that was because I wanted to leverage that with medicine. It's not really commonly seen in the States and also just like worldwide. I believe that 5G is like how 4G used to be and how 3G used to be. And I also think it's similar to a software update where the newest thing is going to be faster and also better at the same time. And it gives us an opportunity to look at where you can improve, and that could be in various regions. And it could be, the beauty about this is that it's global now, right? And like I remember before, people used to use calling cards, and now you could actually set up networks and have like a community of people globally, which is incredible. This is how we're able to do this. I think what I'm more excited about is medicine, because I think that there's a lot that hasn't been discovered yet. I mean, the human genome was discovered and the entire sequence was discovered in the 2000s. So that is still being extracted right now, which is still kind of crazy to think about. And being said that, I think that there were a lot of things that were brought up during the pandemic, such as real-time doctor-patient interactions, which were done through telehealth. And I think that has become more normalized. I think that it's become more accessible and more available to people all around. It's improved trust. I think even its cybersecurity is as still as it's much as it's a risk, it's still more of a advantage at the same time, particularly for people in rural and underserved areas where there's also a short supply of physicians and other healers. I also believe that mental health and counseling was also taken for advantage during the pandemic. And that's also when people started to accept it a lot more too. I think that a lot of people started to take care of their health more, mentally, physically, emotionally. And I think that when you can take a video and do it from anywhere, it doesn't really give you a reason to not take care for yourself. Regardless of the connection issues, I think it also gives you more accountability for your own health as well. And that being said, it gives you more of an idea of actually being able to see your doctor whenever you want, and also keep up with your own progress so you could advocate for yourself and streamline your own healthcare process. With telemedicine now, I think that it's improving hospitals worldwide, but it's also making a challenge with cybersecurity in itself. I also think that there is a need for it globally because yes, 5G is available in the States, but it may not be available entirely in like certain parts of India, certain parts of Africa, and like other rural areas. So it's like, how do you actually get those, get that technology in there? And what was really surprising to me was when I worked for UNICEF, I love the fact that they use Internet of Things in war zone areas. I was so shocked at the fact that they could use that for good. And I really wanted to figure out how they did that. And if they could do that, I think that people in the States could actually utilize that. And so when I came back, I worked for Department of Public Health and as an epidemiologist, which is great. And then that gave me more of a deep dive into population health. And then right after that, I actually had an encounter with my own grandma. And so what I did was during October of 2023, this was like when a lot of political stuff was happening, but at the same time, ChatGPT was on the rise too. And that was like my favorite part. I wasn't in medical school or even studying for the MCAT, which I am right now, but at the time I was utilizing ChatGPT just for fun because I love technology and I love the newest thing that came out. And um, I took, when I was taking care of her, I actually took her lab results every single day and I utilized them into ChatGPT. I also created Sanskrit for her because she understood it. And so I created diagrams just to show her and provide her health education, because I think at the same time, technology can be used for good. And I think that, yes, there are translators available, but there's over 300 languages in India. Not everyone's going to understand the same dialect. Then that goes for like any other country. I think that there's not one specific dialect that's going to be understood for everything. And so I think that when I took this, I trusted the computer a lot more, to be honest. And I was able to give her four more months to live because of this. I was advocating for her, and I was at the same time explaining to her her illnesses in a way that she understood it. I dissected it in a way that it was basic for a 5-year-old to understand. And it's like, how do you take this data and actually create a story with it? And I think that's the beauty of human interaction and human intuition. I had stepped away from medicine for a while, and I think more recently by meeting a group of doctors that really showed me how to take AI and also medicine and combine that with population health. It really astonished me to come back into medicine, and it really got me excited to dive into what I don't know already. And so I think the benefits are there's remote surgeries and robotics. So there's surgeons using robotic arms to perform complex procedures from a distance, and that like the reliability on 5G is low. And so you can get real data real fast, including in unserved regions, especially during a global health crisis, which was incredible because I saw that during UNICEF. And then I also saw that within Los Angeles in my own backyard, which I loved. Um, and so I also like the fact that you could actually use it for imaging. So MRIs, CTs, PET scans. I think that humans are good at their jobs, but I think that when you leverage that with technology and also computers, you could get it quicker. You can get it probably more reliable at the same time, because I think humans are doing so much at the same time, and streamline a better treatment plan for them and give them more options as well. I don't think there's one standard way of doing one certain thing. I think that there's going to be so many avenues of being healed as to however the patient wants to be healed, right? And that goes to training and education. It's providing the health education and almost diminishing the type of anxiety that they would get when they're hearing that illness or disease, and giving them real-time feedback within that same exact framework. I think it's beautiful that kids get to understand their diagnosis with like video streaming and augmented reality. And I think in the future, there's going to be a lot more of that too, which I'm very excited about. And then at the same time, it gives you opportunities of growth, right? So I think a lot of areas have the infrastructure developed yet. And so deploying that out, deploying 5G infrastructure, creating that is going to take some time. And at the same time, I think it's going to ensure, you have to ensure data security and privacy all around, like globally. And then address equity and access. I think that a lot of people are in poor underserved areas, and nothing changes if nothing changes. And so I think that like giving them an opportunity to actually see the tools and see the benefit of that is also beautiful at the same time. And providing them with the health education too. I think worldwide, I think a lot of people are unaware of the type of illnesses and issues that occur, and that's just because they're not available to it. You know, they don't have access to that. And so I think the future is going to be how we've seen it to be, right? It's going to start out with 3G, with 4G, 5G, and basically it's already here, and this is going to be the future, which is probably going to be robotics and VR and augmented reality. I think it's also going to be great for personalized medicine, particularly because I think medicine has been worked in silos for the last like centuries, and even in medical school, I think that a lot of things are still standard, which I think that if technology improves, education should improve at the same time. And so personalized medicine, we could definitely see them in like drug discovery, endocrinology, nephrology, neurology, like biomarkers. Like that's exactly what I did with my grandma's labs. I like literally tracked all her biomarkers and tried to make her understand it, but also at the same time, I took her diseases and I was like, okay, how can I understand it in the way that I can help her and save her? And so there's a saying in public health where you know, there's just accessibility, affordability, availability, and I also think it's acceptability as well. So I think that's a really good example of that would be mental health, whereas like telehealth for mental health was like not greatly available before the pandemic, but after the pandemic and during the pandemic, we saw a rise of that. So I think that even with like 5G technology and like AI, I think if someone doesn't know it yet, they will have to know it, because it's going to be like how like when the iPhone came out and everybody didn't know how to use it, but then everyone learned and it became accepted, and now that's the norm. Like having apps on your phone is the new norm. So it's a really exciting time. Thank you, everyone, and thank you for the opportunity as well.
Oh, that was fantastic. Really appreciate that. Thank you, Sabah. And our next speaker, Enric Pardo Grino from Luxembourg, to present on handover challenges in satellite communications. Over to you.
Hello everyone. Let me share the screen. Do you see my slides?
Yes, sir.
Okay, sorry. Okay, so thank you very much for the chance of speaking here. So far, very interesting presentations. On my side, I will introduce one of the projects I'm working on, which came from this satellite communication problem. So I will just briefly describe for those who are not who don't know about what exactly the handover is, and how the satellite communications can enhance this new 5G 6G era. Then how this brought our Leone project. Then I will dig a bit more in these handover algorithms. And finally, I will explain the particularity of our use case here in Luxembourg. So just for those who are not aware, the handover is basically when a certain user needs to switch from one base station to another during the connection. It can be because it loses the connectivity, or to improve some KPIs, which are more restringent in new technologies. So far, we don't actually notice when a handover is done with terrestrial communications, because it has been studied for many years and it's already standardized. Okay, so this on one side, and then due to these new requirements on these 5G and 6G technologies, we wanted to include a more heterogeneous system in addition to the terrestrial networks with the integration of satellite communications that improves the user experience in either remote post-disaster areas or even some areas in which we require extra connectivity. So while this provides a good great benefits for that, it also poses some challenges. So for instance, the high mobility of the LEO satellites imply that they are only line of sight, so they are only on the point of view of the terrestrial nodes or the users for a short period of time. So this increase of the number of handovers and the number of links that the terrestrial nodes can connect triggered so to fill this gap, we started a 3 years research project that it's basically this low latency command and control via LEO satellites, shorted as LEONE. So basically, the idea of LEONE when ground networks are partially unavailable or completely unavailable, either in a military or disaster scenario, we want to command these autonomous vehicles using LEO satellite constellations. So to choose which satellite the vehicles connect to are basically the most the main objective of the project. And besides that, we want to provide different KPIs related to 5G and 6G, like reliability and latency and so on. When we talk about handover optimization algorithms, we have different elements. First of all, we have the system design, which basically it's a kind of the playground. I will go more into the detail later. Then the scenario and the input parameters, which are, it can be very similar, but they have their own differences. And then the optimization strategies, which we'll not get into because it would take too long, but basically it's how actually the handover algorithm works. We will treat this as a black box, and this will lead as an output parameters that we will evaluate to study the quality of the algorithm. So digging a bit more into that, so the system design basically are the scenario elements here. We need to take into account how heterogeneous is the network. So for sure we will use LEO satellites because we are focusing the project on that, and terrestrial users. But then the question is, do we have also base stations, terrestrial base stations? Do we count on some nodes in the ground? Is the terrestrial network partially available or completely unavailable? And then do we have some hubs or UAVs acting as relays, for instance, in the dense scenarios to, as I was saying, to provide relay between the LEO satellite and the terrestrial nodes. So to evaluate how many satellites or if we are using terrestrial base stations and UAVs as well, should be the system design. And then in order to evaluate the handover, we have first what triggers the handover. So how do we want when are we starting the handover? It's because the received signal is lower than a certain threshold or than the sensitivity of the terrestrial user. It's because of the service time of the user. The service time and the elevation angle are related to the angle and the time that the user will see the satellite. It's the network load. And the difference between system parameters and input parameters is that while input parameters are measurable things that changes over time, the system parameters are used only to simulate the scenario. So for instance, how we model the channel that will affect the received signal, the density of the users and the satellites, or the mobility. So then, as I was saying, from triggering the handover to output parameters, we will consider a black box. And on the other side of the black box, we have the output parameters. The output parameters will serve to evaluate the quality of the algorithm that we study. This algorithm can, as I was saying, we will not get into the detail about strategies, but it can use graph theory, it can use heuristics, it can use machine learning. And this output, the main two output metrics are the handover metrics, being the number of handovers, the handover delay, or the ping pong effect. The ping pong effect is basically when you are connected to satellite A and you suddenly change to satellite B to after that in a short time come back to satellite A. With an intelligent algorithm, you shouldn't have done this change, this sudden coming back and forth from a satellite, because we need to remember that anytime that a handover is attempted, the risk of a link failure is high. And then the second most important output is the signal quality. So we also want to ensure that when we do handover, we want to maintain the signal quality, which will basically evaluate how good the communication is. And then other parameters such as the latency. Of course, the latency that we can control, because due to the high distance to the satellite, from the terrestrial point of view, the latency which will be much higher than in terrestrial communications, and also other input parameters as the overhead that include this handover, or the energy efficiency, or the quality of experience. The quality of experience is something that it's not a parameter that we can evaluate per se, but different research works treat this as how the user perceives the quality of the call in terms usually of a weighted average of different of the parameters shown. But each research work describes quality of experience differently. And finally, I just wanted to mention in Luxembourg, so we are enlist a public research center in Luxembourg, which is a very small country, with borders in Belgium, Germany, and France. Actually, when you see this arrow is Schengen, which gave the name to the European treatment, that has a border between Germany, France, and Luxembourg in the same small village. And why I'm saying this, because being a small country, it means that it has several borders. Each country has its own regulations, so the communication protocols between the borders are also making the communication challenging. So we have done several projects based on cross-border communications here in Luxembourg, such as 5G Inside, which is was a security in cross-border areas in partnership with France. But what I wanted to say here is that, just to finish, that having these challenges in terrestrial communications, in addition to these satellite fast-moving satellites, it also adds another layer of challenges. So just to wrap up, we started because a SATCOM handover is complex, especially in LEO satellites due to high mobility and the short line of sight of the duration of the handovers. This gap of studying in this heterogeneous network brought Leone, which is a 3-year project started in end of 2024, about developing a low latency communication, intelligent communication. And we also check that there are different parameters, system parameters that depend on the simulation, input parameters that we can use to trigger the handover, and output parameters that will be used to evaluate the quality of the algorithm. And that if we, on top of that, we add these cross-border challenges on the terrestrial cross-border connectivity, we have even another challenge. So which can lead to future projects. This is something that has started, but as time goes on, more complexity on the network and more KPIs will require a more intelligent handover algorithms. Thank you for listening, and that's it.
Fantastic. Thank you so much, Enrique. Really appreciate that. I would like to introduce our next speaker, Professor Dr. Erica Young from Oxford, United Kingdom, to present on emerging 5G-enabled advanced healthcare applications with AI, IoT, and AR. Over to you.
Sorry, can you see my screen?
Yes.
Okay. Hello, everyone. Wow, what a fabulous session! Such a spectrum of a fascinating presentation. All right, thank you very much for the invitation. It's a pleasure to be here. I'm going to talk about a sort of emerging 5G enabled advanced healthcare application, but really what's happening if you sort of pay attention to the technology space is really that we are now literally in the last few months, last year also, you can see there are three things happening. One is the huge drop of AR glasses, this more advanced, highly interactive glasses or hardware. Second is the decrease price or cost of producing very powerful AI model and AI capabilities. The costs are going down, but also the capabilities of AI are rapidly rising. And third is actually 5G itself. There are various numbers, depends on where you read it, but in essence, the 5G coverage globally is anticipated reaching 50% globally in a few years' time. Now, all those things are happening right now, and very at a fast pace, perhaps will be faster than anyone anticipated. But what that means from an application point of view, particular healthcare point of view, is that we will reaching a point, so converging at the point that all this deep technology advancement means that more advanced healthcare capabilities are going to a lot more accessible to a lot more people at scale. Now, in this presentation, I'm going to talk about basically two things. One is the trend, what we have seen in healthcare, what we have seen in the technology space. And then I'm going to get into a little bit about what we are doing, not specific technology application or projects. Those we can discuss if you're interested. We can explore that individually. Please do get in touch if you're feeling interested. Now, first, I would like to talk about healthcare. Now, healthcare starting point is that the global healthcare system is changing rapidly. Now, there is what we call the technology push, but also the market pull. Market pull is more taking if you step back a little bit, the societal change, the demographic change in terms of the aging population, aging workforce, particularly in the developed country, but also in other areas like East Asia, China, Japan, Korea, for example, USA. I mean, all these are happening sort of at the global scale. But on the other hand, there is a huge push in terms from the technology side, just as I mentioned just now. Now, particularly from healthcare, what that means is that healthcare system is moving basically from the traditional how healthcare is being done, being seen, being used from, for example, in three keywords I wanted to highlight here. One is what I call the prevention. Well, not what I call prevention. It's actually healthcare is moving from the traditional, very treatment-based. When you feel something wrong or when you feel something not quite right, you go to the hospital, you go to see your doctor, you go to the particular sort of diagnosis center, outpatient, and all that. Now is moving away, not necessarily away from that. It's actually now is broadening to that prevention front. The reason, one of the major reasons for that is that the cost of delivering healthcare is becoming this more treatment related, more we call it reactive related approach of treating people is actually no longer works. Basically, the healthcare system, particular, is under a huge amount of pressure. Is, for example, the COVID actually is one of the case that we've seen that sort of quite recent case, we've seen that vividly, still very fresh in everyone's memory. But on the other hand, this sort of huge rise of complex disease, complex longer-term disease, but also the number of people demanding healthcare resources is rising very rapidly, particularly at the sort of aging, older population, 65 plus. Now, what that means is that prevention-based approach is actually enabling a lot faster, better, and cheaper, and more cost-effective, because if we can intervene much earlier. The second one is decentralization, what I call. Now, what that means is that traditionally it's all hospital or center-based treatment, but now it's moving away from that particular center. It's actually into this hierarchical space, into community, into hierarchical service delivery phase, community in the UK, we call it the primary care and the community care. Basically, as those care is forming a hierarchical system with the centralized system, healthcare system. But that demands much more adaptive, responsive, intelligent, and flexible approach to integrate them, but also ensuring the connectivity. The speakers earlier talk about connected healthcare. That's precisely where it's happening. So what if we can really not only leverage the centralized excellence in terms of the existing healthcare delivery method, but also localize those delivery capability in a local community in the primary care setting, basically at homes. That you might have heard a lot of things about virtual ward, a hospital at home delivery, and all that. Those are really the movement of this decentralization. The third is that in terms of medicine, in terms of medical services, that's also moving away from this what we call the reactive. Basically, when things go wrong, people come to see you. That's reactive approach to the more proactive approach. This really signified by a lot of large-scale screening in the community, in the health center, and all that at home sometimes, even to enable those delivery. The second is that I wanted to say a little bit about 5G. 5G has been around for quite a while now. It's evolving, but so far, if you look at adoption in Europe, adoption in other places, 5G services is there, 5G phones are out there, or devices are out there. But in terms of adoption for real application, particularly enterprise application in healthcare, for example, it's actually, there is a sluggish adoption in terms of the convincing use cases. It's not really, really in terms of scale. You saw a lot of ambulance use cases. You saw those hospital sort of organ transplant use cases sometimes, but those are really sort of tips on the iceberg. There's a huge, vast range of use cases is not being showcased because it's not there. One of the things that I believe that things is going to change is this rise of AI, because once this intelligence and the cost of those AI decrease, and then all those edge computing network, well, they call it pervasive network APIs, basically more flexible resource of the network, as well as the more optimized resource from the network can be released or unleashed to the application level. A lot of things can be done in a way that previously impossible, if that makes sense. But what that means is also that we will have a range of new services, new in the sense that not that they haven't been developed. Actually, they have been around for a little while. Even you can buy those services, such as the what they call the rich communication services, which is basically the new generations of replacement, almost like not replacement. It's the next generation of SMS. So basically, is instead of just the text messages, you have a rich media of services, including the voice, image, video, live stream, group communication, and all that. But then all these are happening at the same time. All these are actually happening in the 5G space. If you look at the particular sort of in Germany, in the USA, in UK, all these services, actually, a lot of this well, at least in patches of testbed, large-scale testbed. They are ready to be used, but waiting for the application level to really leverage those. One of the things is that in theory, what I believe is that in theory, because we are now at this tipping point, if you like, this converge, all these things starting to converge, actually, what I believe is that in the next few years, we may see a lot of mobile apps going to starting to diminish the number of them because of the empowerment from the network, from the telecommunication services providers, such as the RCS, such as the network APIs, advanced network APIs, and also the edge compute capability is going to transform how people access services. In theory, with all this AI, AR, and a powerful network of 5G, do you really need those so many different apps? We believe that it's in theory, maybe not. In theory, the apps, one app can really replace a lot of the app currently in the market. Now, in terms of the company, our focus is really focusing on revolutionizing complex care with technology. So what that means is that instead of developing, we call it a pawn innovations, such as one medical device for this care, for that, we actually thinking about the system level changes will be really important. That is basically addressing that shortage of staff, addressing the limitation of across the board, across globally, about shortage of specialists, nurse specialists, in terms of the specialist clinicians and all that. Those are biggest challenge facing the sector, the human resources, particularly specialist human resources. So, but then how do we do it? Well, first of all, why we do it? On the top right-hand corner, you can see some statistics globally. But in essence, one of the biggest things is that a lot of this devices, a lot of the pressure is actually coming from what they call the chronic disease, basically such as stroke, such as respiratory disease, healthcare, and all that, from respiratory disease, heart disease, cardiovascular disease, and all that. That occupies a huge amount of medical resources, if you like. So that's really what we are focusing on. In terms of what we do, we are basically focusing on 3 areas of development in collaboration with our partners, as well as research institutions, as well as the commercial partners. We are developing actually more in the IoT space. We are actually developing the infrastructure to connect different medical devices. In the sense that to support the remote health monitoring, that will be sort of understanding people's mobility pattern, understanding people's behavioral patterns, but also understanding different sort of the medical symptoms, capturing those medical symptoms early on in combination with a variety of other type of sensing capability, if you like, the behavior, the mobilities, and all that. But secondly, also interestingly, we talk about care, right? Care is really about a care delivery that can be happening in care homes. Well, in the UK, we have nursing home, we have care homes. Basically, there is a place you go, and then it's a facility base. Second is the home care. And third is the home-based care by family and relatives. So basically, we believe that by leveraging all this technology, we can transform that type of care delivery and care services at scale by changing how carers, patients, caregivers, professional caregivers, and care providers work together. We can use technology to do that. Another thing is that this rise of AR and a rise of AR in terms of its capability, but also integration with AI and IoT devices, we believe that will kick off a spectrum of new range of medical technology-enabled medical interactions, basically reducing people's needs face-to-face doctor appointment, face-to-face emergency A&E attendance. Those will all be happening. And rely on, for example, those 3 areas of capability offering by AI, such as edge computing. That's AI for particular, we see the use cases for interactive, highly interactive, such as AR glasses, but also on-premise applications. Those applications demand higher privacy protections and sensitive about their data. Second is that about particular as of now, is about the more flexible network services responding to this hybrid IoT, which is low bandwidth but low data rate, but also versus the AR and the real-time video-based consultation, which is high bandwidth, high interactive, but also hybrid data traffic. That demands the network to be a lot more adaptive, flexible. And third is that this RCS, which is the next generation SMS and all that for rich media, which is really important because we see that as a vehicle driving this indoor-outdoor behavior, mobility, medical symptoms. So you can basically understand and support your patients from a care point of view, from a healthcare delivery point of view, in a much wider context, not just the indoor, not just in the clinic at home, but actually connecting them across the board to the outdoor space, which is basically what you want people to do at the end of the day. Right, so I will go to the next. This is our sort of contact details and for some information on project. Thank you very much. Okay, I will stop here.
Oh, that was brilliant. Fantastic. Thank you so much, Prof. Erika. I really appreciate that. Let me introduce our next speaker, Professor Dr. Roman Odarchenko from Kyiv, Ukraine, to present the role of 5G, 6G cellular network in achieving the goals of sustainable development. Over to you.
Hello, everybody. So I guess you can see my screen. So first of all, thank you for inviting me here. So it is a great pleasure to be here and to have an opportunity to present some speech. So today I will speak about the role of 5G and 6G cellular communications in achieving the goals of sustainable development. So first of all, I would like to make the brief overview of what I will talk about. So yes, I will introduce the sustainable development goals in any case for those who are listening to us. The next, I will highlight key features of 5G and 6G technologies, which are related to sustainable development. Also, I will discuss impact on sustainable development goals of these technologies. And also, I would like to mention and highlight the challenges and risks which we are facing during the achieving the sustainable development goals. And of course, I will finish with the conclusions. So first of all, just a reminder, what is United Nations Sustainable Development Goals? They are a universal call to achieve a sustainable future and promote equality, human rights, and justice for all by 2030. So it was adopted in 2015, and the agenda is working until 2030. So here on this slide, you can see an overview of sustainable development goals, which were agreed during the previous conferences of the United Nations. So the SDG established a blueprint for global citizens to work together to build a better world. For it is only by working collectively across borders and disciplines and with community partners, and that these goals might be achieved. So you see here on the slide some of all of these sustainable development goals. So no poverty, zero hunger, good health, well-being, quality education, and so forth, so forth. So there are a lot of many goals that we need to achieve. And today I would like to showcase how 5G and 6G technologies can contribute and can help us to achieve the SDGs. So first of all, again, just a reminder where we are. So we are moving towards the 6G evolution of cellular networks. We started with the first generation of cellular networks and went through a long and difficult way towards 5G. Now we have standardized 5G network. We have a lot of commercial projects, a lot of commercial networks which are working all over the world. we have private networks, we have IoT networks, we have machine time communication and other types of networks. So we have now much higher data rates, more than 10 gigabits per second. We have much lower delays, up to 1 millisecond in these networks, and we have a very huge connectivity density in these types of networks. And all these networks, they will help us to achieve the sustainable development goals. But we are not stopped yet, so we are moving forward, and now we have the standardized and frozen the release 19 of 5G networks, which brought a lot of new innovations and a lot of new capabilities to the subscribers, to mobile network operators, which help us to achieve different network service KPIs, quality of experience, and so forth, so forth. So, but we are not stopping. We are moving towards 6G, and 6G will offer a variety of different new capabilities and benefits. For example, extreme high data rate and capacity. We will receive much higher peak data rate, more than 100 gigabits per second. Extreme coverage, gigabits coverage everywhere we will receive. Extreme low energy and cost efficiency. Extreme low latency, less than 1 millisecond. I even cannot imagine how we can achieve this, but it was promised by the developers of the 6G. Extreme high reliability, which is guaranteed cost for a wide range of use cases with 7 nines, you can see reliability. Also, we will provide with the 6G secure, private, and safe and resilient connectivity to all the subscribers in the network. And of course, 6G will help to achieve the extreme massive connectivity in these commercial networks. But how these very beneficial and very innovative networks will help to achieve the sustainable development goals? So on this slide, you can see some areas in which we can contribute. So for example, in ultra low latency networks, so both 5G and 6G networks, they are designed to offer incredibly low latency, and it is crucial for real-time applications. And under these applications, we can consider health care as an example. For example, again, remote surgeries, transportation, autonomous vehicles, smart grids, and smart cities, smart buildings, and so forth. And everything will help us to achieve the SDGs in these areas. The next is a massive connectivity. 5G enables the connection of billions of IoT devices globally, and paving the way for smart cities, again, smart agriculture, smart industries, all of which contribute to more sustainable practices by optimizing resources and also reducing waste. The next is energy efficiency. So 5G and 6G in the future, they are designed to reduce energy consumption through more efficient data transmission and smarter infrastructure, and it will contribute to a reduction in the global carbon footprint, so which is one of SDGs. The next is enhanced network reliability and speed. So here, networks will ensure reliable and high-speed connectivity, which can drive digital inclusion by enabling access to education, telemedicine, and other essential services, even in remote areas, supporting goals like quality education, healthcare, and so forth. And the last one on this slide is an integration with advanced technologies. So 5G and 6G will integrate artificial intelligence and other developments like edge computing, blockchain, and it will enable innovations like predictive maintenance in industries, smart environmental monitoring system, and secure data sharing for sustainable development initiatives, which will be launched in the future. And the key areas of 5G implementation in terms of SDG are the next. So transport, so it can be summarized as it is represented here. So in transport, we can contribute to smart transport, real-time fleet analytics, fuel optimization, autonomous transport, and so forth. In agriculture, we are talking about smart animal tracking, about localized pest and herbicide. In utilities, we are talking about smart grids, smart water management, and other smart systems for in this direction. And also for the cities, it will bring benefits like smart waste collection, real-time traffic management, and others. So here on this slide, you can see some examples of already existing solutions which are showcasing how we are contributing with the 5G and 6G in the future to the achievement of sustainable development goals. For example, Telia and Ericsson autonomous electric bus solution relies on 5G network capabilities for live video positioning and prioritization. So, and during the trials, 5G control towers were used to remotely control buses and transmit real-time video to track journeys and ensure passenger safety. So, and here automated vehicles enabled by 5G IoT technologies, which are more fuel efficient than manual alternatives, and it help us to reduce greenhouse gas emission for public transport and make this public transport more accessible and lower operation costs. The next solution from Proximus for weed and pest control, which uses drones to capture images of agricultural plots and artificial intelligence to identify the nature of weeds or diseases in crops. So, and what I would like to highlight here, so instead of treating the entire field for pests or diseases, this solution allows farmers to treat only the affected areas. And by 2030, in comparison, European farmers will have to reduce their use of pesticides by 50%. And in this test case, Proximus found that pesticide use could be reduced by 80% even. And the last example on this slide is a city of Rotterdam smart waste management system. So this management system uses the IoT sensors which are connected to 5G network, and again it helped to build up the dynamic roads for collection of waste for the vehicles, and in turn this resulted in 20% reduction in CO2 emissions, as well as a 25% reduction in labor and equipment costs. So these are only few examples of how these 5G solutions connected with other IoT IT technologies can bring benefits to the development and achieving the sustainable development goals. But we have some challenges and risks of 5G and 6G technologies in the future, which are related to sustainable development. The first is a high energy consumption and environmental impact. The second is a digital divide. The third one is a cybersecurity risk. So we need to improve the technologies and cybersecurity solutions to ensure that everything will go in fine in these types of networks. The next one is a cost and infrastructure requirements. So we need to reduce for 6G at least the investments to these networks. We need to reduce the number of base stations, other cable infrastructure, and so forth, so forth. And of course, the last one on this slide is the privacy concerns. So we have a lot of new connected devices, and in the future, in 6G, we will have more and more devices which are connected. And in these conditions, we need to ensure the strong data governance policies to ensure that sensitive information is protected and individuals' privacy rights are upheld. So, concluding, I would like to say that 5G and 6G, obviously, they have a great potential of in transformation, in digital transformation, and they will support smart cities, enhance healthcare, enable efficient resource use, aligns directly with the United Nations Sustainable Development Goals, SDGs. Also, 5G and 6G, it is an enabler of global change. By connecting people, industries, and technologies, 5G and 6G in the future will serve as key enabler for addressing the key challenges like climate action, education, inequality, and urbanization. But we need to overcome some challenges which are connected with high energy consumption, digital inequality, cybersecurity risks, and so forth. But I guess that together we will face these challenges and fight against them. And the last one is what I would like to mention, that with the help of 5G and 6G, we will receive the sustainable future. So let's work together on development of novel solutions for innovative 5G and 6G networks. Thank you for your attention.
Fantastic, Professor. Thank you so much. And I would like to introduce our last speaker, Mandy Oswald from Dresden, Germany, to present IoT in SME business cases. Over to you, Mandy.
Thank you very much. Thank you for having me. I'm just sharing my screen.
Let me make you a co-host, so it should work now. Yep.
Okay. I hope you see the right one.
Yes.
Okay, perfect. Thank you for having me. Thank you for the invitation. So I'm the last speaker today, and I will tell you something about IoT in SME, small and medium enterprises. So business cases we will develop and show on a business fair very soon in Germany. You see that I'm just checking twice because I see myself. You see the whole presentation slide, yeah?
Yes, because you are using two screens, right? So that's the
Yeah,
reason I
I'm
have.
confused with the screens right now. Sorry.
Yeah, if you switch off one, that then it works very well with one screen.
Okay, just a second. Always you think you have everything prepared and then something is surprising you. But I guess you can all relate. Okay, again, changed the wrong ones, but I gave it the last sentence. It doesn't show me to the other. Let me to the other. Okay.
All right.
Now, because I almost swear it let me do it.
Okay.
Sorry for the craziness. I hope you can cut this out. If not, then we see the others. So I would like to start with a statement of our CEO of Vodafone Business IoT, Eric Brennies, and he said, like, Vodafone IoT is the global IoT one-stop shop. It's created to improve people's lives and help businesses of all sizes to be more competitive, resilient, and efficient. Which means we have like a giant, I always say like Lego or like any stones, you can add all little details. You can come to us and let us know what would you like to do with your IoT case. No matter if you can name it yet, we can sort it out and we can make workshops to define it, and then we can help you to get it done. So as my colleagues from the conference today said, we have like the Internet of Things. It's like a very important step of the digitalization, and you see the IoT is like in the middle, in the hard part, if you would say like this, and you can use it for all different parts of the digitalization. So for product development, for customer service, like chatbots, we're using many chatbots, or we exploring and making chatbots for many companies at the moment. For device management, workforce automation, so for example, asset tracking or service billing or remote monitoring, so nobody needs to go to scary or dangerous environments. So there's a giant field where we could use IoT cases. And I brought you some, which we will show at the Exponential Europe Fair. This will take place in Düsseldorf from the 18th till the 20th of February, so very soon, in hall number 1. And it's an international trade fair. It's the first time it happens in Düsseldorf, and it will take place with an international audience, international partners, and we are there with as a 5G connectivity partner. Also with a private 5G campus network. So we installed many campus networks within Germany or worldwide, and this is important for companies who need or have a need for maximum speed and low latency, and also for special cybersecurity needs. So it's like a private, as the name says, a private campus network where you can make sure that no threats will be exposed to your business cases or to your business itself. And it's perfect also for autonomous systems, robotics, and more to come. So I'm really keen what's happening there on this trade fair. And next, I will show you some of the cases we will show there. So for example, we will take there the Vodafone Redbox. It's delivered and not delivered. It's standing usually in Düsseldorf. So it's like a home run for the Redbox, and it's a size of a telephone box. I don't know if you remember how the telephone box looks like. It's like some years ago. It enables a mobile private network, an MPN, and you can use it for multi-access edge computing. So it has ultra low latency and can use for AR or VR cases. It's like mobile, as you can see, and you can use it for robotics or smart factories, or you can use it as an add-on, and it can be adapted to any environment. So this is a showcase we like to show and on many events. The next one, I'm just flying over the little, or not the, I'm giving little sneak peeks of the cases we take. So the next one would be DroneNet, which is also based here in Saxony. And as we have here also like a Vodafone Tech Innovation Center where we explore and like make up all the new showcases, and we have many engineers here working on that. So DroneNet is one of them, and it's a digital tool, so it will help the drone pilots, because usually in Germany it's really hard to get all the legal restrictions or to follow them, because it's like as you know, Germany has a law jungle. So we can use DroneNet to identify potential risk and avoid accidents and be sure that we are safe with all the legal restrictions, so we don't violate them. It's based on 5G and cloud data, and not on Wi-Fi anymore only, but it can be also with Wi-Fi, and it provides real-time information. For example, also on hazards, on dangerous situations, or on where you're not allowed to fly, or legal restrictions, or even weather conditions if a storm is coming up or whatever could happen to the drone. And we will also show that you can control the drone with AR gestures. And this has to be with 5G instead of Wi-Fi connection, because the Wi-Fi could be interrupted or too slow. And the AR headset shows you the position where it is, even if you can't see it like in real life. So you can use it from here, from the closer distance up to 5 kilometers. So if you can't see it with your eyesight, you can still see it over the AR goggles. And the next one is the Mobility Lab in Altenhoven. And it's a center for mobility solution, also for connected automotive solutions. It's worldwide unique, and it's like a radio test field where we can test anything with 5G Center of Excellence. And it can be tested for the connected mobility, or automotive companies use it there, tech companies use it, and scientists and students. They work together there, and they can simulate realistic traffic scenarios and can so use all their data to explore more or to define the next step of the inventions. And another one is Eule, which means owl in German. And this is a transport solution for medical stuff, like, for example, blood or tissues or samples or whatever needs to be fast from one point to another. And it's transported in an unmanned aerial vehicle. So it's a construction of a drone arm, and it determines the position of the unmanned flying object. And so it can ensure a secure landing of the drone, which is necessary because of the important samples or blood or whatever it has, like medical stuff inside. So this is also a really interesting use case you can see at the trade fair. And also Spot. I think everybody knows Spot. So we have Vodafone Spot, and he's like, he or she is an agile mobile robot, and it can navigate in any terrain. It can grab stuff, it can place something there, it can push, it can pull. We had it at diverse trade fairs or like exhibitions, and it can communication, or it has communication skills with the operator. It can communicate with you. We had it bringing popcorn at one trade fair to the customers, so that was really fun also. And another use case is, for example, at the BASF campus. It will go to dangerous area where usually it needed to be checked by people like twice a week if everything goes right in the manufacturer or in the company itself. So now they don't need to be exposed anymore, and so no people can be harmed anywhere, because we can set Spot there, and he will send all the data to us which is needed. So yeah, all these automating routine inspections Spot can do, and can safely, accurately, and frequently capture all this data and bring it to the people. And the next is the Giga AR stage. This is like a table. I also brought a video in the next slide, where you can put anything on the AR stage which you want to exhibit to your customers. For example, here it was like some suburb, Berlin, as you can see. And I will go to the next one to see. You see like the Berlin Dome, and then, for example, this would be a use case, or it was like for a city, and then they were bringing information about the buildings or the suburbs, and it's good for people who want to invest in the suburb. They see like, or they can zoom in and they can see like what's happening there. Is it good for me to invest there, or like should we go somewhere else? What is missing in the infrastructure? So it's really interesting. You can also do it like for any other showcase, because anything can be displayed there. So it's a really cool device, and you can also display it in the middle of your room. If you have a conference, you can see it like with the Googles, and you can turn it around and see it from every point of angle. Yeah, another case is the Mercedes booth at the IAA in Munich. And we had this because there were many visitors expected for the new model. And because they had not like 20 cars of the new model there, we had to find something like XR, like a virtual. And so it was like really low step to reach it, because everybody could like download it with a QR code and on the web app, and so you didn't need to install it. And so you could have the same experience as somebody who would touch the car, but it was like crowded with people, and you could still feel it and get more informations about it, and you had it on your device on you, so nobody had to queue or had a long wait. So that was also really interesting. Even if you're not on the fair, you could experience the new model and see and feel the insights. Yeah, and this is another one which we had at the Opera House in Düsseldorf. It says like the German opera on the Rhine, and we had a special Google, so you could like you had extra information on the Googles. You see like in the pictures here that you could have extra information about the opera singers and about the play, or could like have detail biographies, details about the orchestra itself or about the music, and while watching it live. So we were testing this in the beginning, and we were overwhelmed because they had so many reviews and so many questions, and people would love to have it like all the time. So we're working on that we can make it possible soon. Yeah, and this is like an overview of other cases we have. So, for example, we have the Giga AR cooking, which is a trend we see. Like people will want to, like for example, with the German market celebrity chef Stefan Hensler. I don't know if you know him. You can have like a cooking show with him together, and it's with augmented reality in this app realized. So it's really fun for the people, and we're getting more and more interest in this. Or we have different showrooms where we can show like what we do, and you could travel through space and experience the showcases we have. We also work on digital health, as we heard today, which is also like a very important field. We have digital health twins, so it means like you have a layer of your body, and then you could see like, okay, what's as a patient, you go like to one doctor and the other doctor, and usually they don't talk with each other, or it takes like really long time to give them all the informations. So we're working on that you see it, and then you see like in your digital twin, okay, like this, I have a problem with my liver, and this needs to be done, and all the details are displayed there. So there's much going on there. Also, like with 5G, there is live operating possible. So this is also a really big field. And another one, but I don't want to go too detailed. If you have questions about anything, don't hesitate to ask me like afterwards. Or the Cologne Cathedral, for example, we have digital twins with specialized drones, which we can do like for any building, like we had before. Or like if people interested in soccer, then you can see like the soccer game live, and over the app you can follow them and see like how fast they run and how possible it would be to deliver a goal. So there are many things we can do. And yeah, I brought some more, but I'm just overflying about them because I think my time is running out. Like for example, this slide is in German, but anyway, we have like sensors for the tires for Continental. We developed with them so they can go like more safe on the streets. They last longer, and they deliver us all the data, like if they still safe, or like if they need to be replaced really soon. Or for example, in lifts, we have like over 100,000 SIM cards like worldwide in the lifts of ThyssenKrupp. Maybe you can check next time you're in a lift which one it is. ThyssenKrupp is usually very popular, and they give like predictive data, so we can do like see in advance what needs to be done, and we can use this with an M2M machine, M2M platform, and analyze all the data to see like what needs to be done in advance. Yeah, or smart metering is also like a big use case we use, for example, for Telecom. We develop with them together, but like it's a huge market in Germany, and so we can go also like in in the low levels where usually you don't have reception of your normal broadband. So we use like narrowband IoT, for example, and we can deliver all the data and save money, save the environment a little bit more, and save time. Or like the last one I brought to you is like we can, with IoT, we track and we can save like really high expensive music instruments. So it can also, there are different sensors inside, and we can track like the position, the temperature, or the humidity. It's like also worldwide, and also like for safety reasons, so they don't get lost. So yeah, we're doing a lot of different things. Thank you for listening. And if you have any more questions, you're always welcome to contact me, and maybe see you one day in Dresden.
Brilliant. Thank you so much, Mandy. I love it, the Giga AR stage. That was so cool. Thank you so much. Let's have a quick 10 minutes among the speakers. You know, I actually thrown a question earlier, you know, in terms the telcos stage right now. Are telcos behind the AI curve? We know that there's a lot of AI stuff is going all around among all the industry sectors. Telco is one of them. And you know that the past 1 week, there's a huge hype on the DeepSeek, right? In competition with the Open AI platform as well. And that actually really shaken up the US stock markets and so on and so forth. We know such kind of AI platforms have really impacted in terms of the vertical industries, horizontal industry sectors as well, in terms of improvise the operations and so on and so forth. So, but what about the telcos in terms of the operations within the telco and also the offerings from the telco? Anyone wants to take up what is your point of view? You know, telcos are really catching up into this AI or still behind? Yes, please.
Yes, actually, I have seen telcos being quite active in catching up with generative AI and all that. Not necessarily just last few days, but actually, I have seen actually in terms of the basically the cloud within the AI, sort of the cloudify, so that type of development, basically embedding AI into optimize the network and all that. That has been a big move in the last few years. But actually, even in the last year also, I saw generative AI itself being used. Well, I'm not saying it's at scale or really production scale, but I do see some movements there already being demonstrated. I've seen that quite actively. Now, that's really about the network operation, optimize the energy use, optimize the response time, optimize for particular application. I've seen that already happening. I guess that's only going to accelerate because telco obviously also need, well, Mandy is here, right? Telco also need the signal from the application from the user side, right? But I think they are very, very proactive already. I've seen that. Yeah.
Yeah, I can tell this is the case, because we also do like, or I can only speak for whatever business by this, but we want to deliver an end-to-end approach. So people need connectivity solutions, and then it will end to the AI solutions. So basically, we do like everything. It starts with a need, and then we will deliver everything a customer needs. And also we have like an XR factory in Germany, or like we have also one in Malaga, for example. But like they're everywhere. So I always say, okay, Christmas is over now, but I always say, what would you wish from business-wise from the Santa Claus? And then people say like, what's their strategy in like 5 years, 10 years? But then we can develop this together with them. So there's no border. It's not something we have or where we stopped. I mean, we don't deliver everything by ourselves. We have a lot of partner. We have a strong partner system. but we can do anything. And this is like, that's why I love my job. So we can explore and get like, it's like being a kid and playing with tools. And the best is like if something comes out with in the terms of AI or XR or whatever it will be, or asset tracking. So it's always fun, yeah. And we are, I don't know if you know, but Vodafone Business is like one of the global players for IoT businesses. But sometimes people think like Telco is only the SIM card you have in your mobile phones, which is just, I don't know, like so many years ago. We're not like this anymore.
You know, these large language models, like dominated by the OpenAI, ChatGPT, DeepSeek, and the Google, Gemini, and Microsoft have their own platforms, Meta. All these are really controlling the whole market, right? In that sense, I'm not sure from the telco point of view, because telco definitely would build their own language models as well from that aspect. Or are they trying to? This the question that I often ask myself: are they have some sort of integration with the this kind of large language models, or they are building their own smaller trained models just to optimize the efficiency, like for example, the personalization for their customers in the telcos. How Nikolai, do you have any point from your view?
Well, I think there is no need to build their own language model. So usually how it works, you take basic model like from OpenAI or Google or DeepSeek or whatever it is, and then you enhance it with your data. You connect your own data. You can fine tune the model with your data, with your examples, and make it more narrowly specific for your business case, right? So that can be adopted for different types of problem. So the same way as we do it for strategy consulting, you can do it for telco, or even for very specific use case in telco. So you can train many different models for now very popular AI agents. Every agent will have its narrow function and specializing in specific tasks. And yeah, so what I'm saying, you don't necessarily need to build your own language models. It is basically already done for you. You don't need it. It's
Right.
huge investment for no reason, unless I am missing something big here, but I doubt.
The only issue is in terms of the security of the data, right? Because of the
So
telcos have
yes, if you
data.
yeah, so I think that DeepSeek is making a huge movement there because they are open source. So basically it means you can take their model, do whatever you want with it, and it will be fully isolated in your environment. So you're not going to share any of your data with anyone else. It can be in fully private cloud or on-premises infrastructure. So that's the beauty of it, as well as other open source model like Llama and Mistral and many others. I believe that there will be more and more very soon, which we will hear about.
Right. Ivan, would you want to share your
Yeah,
point?
sure. From my point of view, actually, from an academic research point of view, I think that telco can leverage AI in order to, specifically for physical layer security, for 5G positioning. Actually, there is a lot of effort from 3GPP to use the AI in order to improve the capacity and performance of 5G positioning, especially in scenarios such the no line of sight scenario, very complex scenario, where it's really difficult to create a model in which you link the measurements to the user position. So actually they are trying to use, there is a lot of effort from many companies actually right now, the most famous one in telco area, that actually are trying to find the best solution in order to leverage AI in order to provide the best user 5G positioning performance, in order to, let's say, find the intricate details of real complex scenarios and try to solve those problems using AI. And from security point of view, actually, I think that they are trying to use them in order to find a solution for anomaly detection, starting from data. Actually, they are trying to use them in order to find anomalies and let's say create alert to the system and to the user when something is going in a wrong way. Yeah.
That's associated with the fraud detections as well, right? Yeah. Anyone wants to add any point? No? So, yeah, please.
Just an observation, perhaps a controversial one. But what I do feel, at least so far in our experience, I think there is a gap between the telco AI and the application AI. Because in order to really, because these two things now is actually application and network actually starting to the boundaries starting to get blurred. So what that means is that traditionally what we see the AI for the network, AI for the application, but what we see more and more is that you need to integrate these two. So that means that maybe a new model or new way of working between this application and network, because this is a really traditional OSI model, if you know what OSI model is. So 7 layers, so very clear distinction, and you said there is benefit for that. But now what I think could be happening, but what is not being done traditionally well by the telco or application developer is that this understanding these interactions, how these two type of AI, application level AI, and in the healthcare, for example, and then the network AI optimized network. How do you make sure these two are, if you like, coordinated or more not synchronized? Synchronized is a very technical term, sounding just minutes or seconds, but it's really coordinating. Then it will be a new type of application. I know it's very abstract, but in theory, I think there could potentially something there. It's not necessarily telco behind. It's a new way of working between the application and the network players or telcos could be evolving, could emerge in the future. Hopefully not too far. Yeah.
Yeah,
Or
this
that's
is a
just an
very interesting
observation.
point, actually. This is a very interesting point. Actually, right now, I think that one of the most prominent solutions that are trying to merge, that are trying to fill this gap is the ORAN Alliance proposal that actually is trying to rebuild the radio access network in order to embed inside the network, inside the radio access network, the AI in order to optimize, in order to orchestrate, in order to orchestrate better using AI features the overall network. In this way, I think they are trying to fill this big gap that actually right now exists in traditional networks. And I think that this is one of the most prominent way in order to do that.
And moving forward from the ORAN Alliance is going towards to the AI RAN Alliance. So that means the AI will be embedded in the radio access network to improvise in terms of the energy efficiency, because when you're moving from 5G to 6G, there's a lot of power usage, right? So how to cut off that? So that is another initiative has been taken in those embedded AI in RAN. So I think this is something cool we can see in the next couple of years.
Yeah.
I think it's very important to say that all these language models, not large language models, they become small language models. And the same way as IoT appeared when you have, all the SIM cards in many different small sensors and devices. Now all these small devices will have their own internal AI capabilities very soon as well. So it will probably take it all to the next level, just because AI is becoming, more and more accessible and, reducing the models.
All right. I think that was really classic. Anyone have any points to address? If not, thank you so much. I really appreciate for your contribution. This video will be uploaded on our YouTube channel in the next couple of hours, and we will notify to all of the speakers. And to the audience, please take a couple of seconds to click the subscribe button on our YouTube channel. Till we meet again, thank you so much. I really appreciate for your valuable
Thank you.
contribution.
Thank you
And
very
thanks
much.
for the
Thank you.
invitation.
Nice meeting you
Okay.
all.
It was a
Bye.
pleasure.
Thank you. Bye.
Thanks. Bye.